This is Dr. Jones checking in. This is a video lecture for ANP1, ANP2 lecture test 1. Yeah, ANP2 lecture test 1, video 10. And this is a redo of video 10 because the previous version had no audio. Well, it had audio, but it was like this weird, like, but like if aliens were doing it, noise. So, like, you could see me and you could see the screen, but no useful audio. So we are going to redo. So we left off, we had just finished page 21 of the note set in the last functioning video. So we are going to start again at the top of page 22. So we are talking about the ear, the inner ear, and what happens there. We have equilibrium, which is, make sure I get all the terms here, which monitors gravity, linear acceleration, and rotation. And for the record, there are two types of equilibrium. There's static equilibrium and dynamic equilibrium. Equilibrium is monitored by the vestibular complex. Vestibular complex includes both the vestibule and the three semicircular canals. And the hair cells are the receptors for both equilibrium and hearing. It says balance. Yeah, that's right. And then they are hair cells and they are mechanoreceptors. So there are mechanoreceptors. That's the one where when you bend the cell membrane, that opens the ion channel. And so the hair cells have these in their hairs. And when you bend the hairs, you bend open that ion channel, allowing ions in or out of the cell, either depolarizing it or hyperpolarizing it. Because remember, you can either depolarize or hyperpolarize a receptor cell, and that will change the chemical transmitter sent across the synapse to the sensory neuron. The sensory neuron then has a generator potential, which generates action potentials for as long as the stimulus is there. Touching it exists. Yeah, I don't know. More coffee. I made iced coffee today, and it was pretty good, except my not sugar, my monk fruit, would not dissolve in it. So I made icebox coffee, and then I had to make a simple syrup so that I could sweeten it, because I had like just a dredge of sugar, not sugar, at the bottom of the coffee, and it didn't taste good. It's much better now. Okay, hair cells. Yeah, we talked about hair cells. What's next? Okay. So the rotational movement. All right, let's talk about the ampulla, showing the ampullary crest with the hair cells. And I'm just going to draw on this one. So the crista is this bump. The crista is the location of the sensory structures. The sensory structures are these hair cells, and they have hairs. And the hairs go out into this structure called the cupula. And this is a gelatinous structure, like jello, that goes the width of the membranous labyrinth in the ampulla. And it's got endolymph on both sides. So when you rotate your hair, oh, and then there's, of course, the sensory nerves monitoring those. So when you, I have a picture, there we go, rotate your head, that, let's talk about the lateral semicircular canal, because it's parallel to the floor. So when you, you're moving parallel, rotation parallel to the floor. And so the endolymph, the fluid in the membranous labyrinth of those semicircular ducts, swooshes around as you move. Swoosh, swoosh, swoosh. And as it swooshes, that's the technical term. It's not, but I'm going with it. As it swooshes, it bends the cupula with the movement of the fluid in the semicircular duct. And when you bend the cupula, you bend the hairs that are embedded in the cupula. And the one thing we know about the membranes of the hair cells is that they're studded with mechanoreceptors, so that when you bend them, you're opening that ion channel. And either, I think the book said that what happens is you depolarize when it swooshes one direction and hyperpolarize when it swooshes the other direction, so that you know which way you just moved your head. So this is dynamic equilibrium, going back, dynamic. And dynamic equilibrium monitors the movement of your head. Okay, so rotational movements activate the hair cells in the cupula, in the crista, and they're in the ampulla. I think they changed the name of the ampulla to ampullaric crest or ampullary crest, something with crest, but the crista is the sensory receptor, and it's one in each ampulla. The ampulla, again, is the swelling, and there's one in each of the three semicircular canals. Okay, so then draw this, which we drew, and label it, label that. And then the hair cells each have, just a second, I have this written down, I think. Okay, there you go. The hair cells are, actually, let's go to this next slide, it has more information. They are monitored by the sensory neurons, and they have 80 to 100 long stereocilia, which are long microvilli. So the stereocilia are microvilli. There's 80 to 100 of them per cell. And each cell has 1 times 80 to 100. Got it. Okay, 1 single large kinocilium, it's the longer one. And when the hairs are pushed, that distortion of the plasma membrane alters the rate of transmitter release across the synapse to the sensory neuron. Okay. Flexion and extension of the head are read by the anterior semicircular duct. Left, this is flexion and extension. And then left and right rotation, we already said, was read by the lateral semicircular duct, so that's your nuh-uh. And then left and right lateral flexion, which the book calls moving your ear towards your shoulder. So much simpler to just call it what it is, which is lateral flexion. And that's read by the posterior semicircular canals. Okay. So this is dynamic equilibrium, semicircular canals. The swellings are called the ampulla, and in each ampulla is a, back another picture, crista with hair cells. And the hair cells are embedded in the, that says cupula under my shoulder, embedded in the cupula so that the movement of the endolymph bends the cupula, which bends the hairs of the hair cells. That's how you know that you moved your head. So that's dynamic equilibrium. What about static equilibrium? There we go. Static equilibrium are read by the utricle and saccule. The utricle and saccule provide position and linear movement sensations, bottom of page 22. Describe the functions of the endolymphatic duct and the endolymphatic sac. Endolymph is constantly being made, but because it's inside the membranous labyrinth, which is inside the bony labyrinth, which is bone, right? You can't have an excess amount of endolymph because, well, your inner ear would probably explode or something. Bad things would probably happen. So we have to constantly drain off this endolymph, and how we do that is through the endolymphatic duct into the endolymphatic sac, and the endolymphatic sac is embedded in veins to filter out excess fluids and wastes and keep the nutrients that your cells need, kind of like the arachnoid granulations draining excess CSF into the superior sagittal sinus. So, a little flashback there. Yep. The hair cells of the utricle and saccule are located in maculae, which is the plural. Okay, I'm just going to find the keyboard because that's faster. Okay. And again, singular versus plural, English versus Latin. One macula, two maculae, A-E, or maculae, or maculae. It's a long vowel either way. The gelatinous masses covered in calcium carbonate crystals are called statoconia. They've changed between versions of the book exactly what statoconia and otolith mean. Otolith stands for forming the otoliths. Yeah. Used to be anyway, otolith means ear stones. So there are people who get vertigo when these otoliths become unhinged. They go and they like push in the wrong place and cause a discrepancy in the messages that your brain is getting. It's just like when you're car sick, if you're looking down at your book or your screen and your ears and your gut say you're moving forward, but your eyes say that you're not, then that causes a discrepancy that can make you nauseous. So if you do get car sick, it's best to sit in the front where you have a good view and then keep your eyes trained on that horizon. Oh, neighbor's taking out her trash. Okay. I keep my window open and so that I don't feel trapped in this little corner. And so when I see, we live at the end of a dead end road. So when I see movement out my windows, it's like, because like very few, it's like a 1 block long dead end road at the end of a dead end road at the end of a dead end road. And like nobody comes out here except like the nurses to take care of my in-laws and, and take the trash people. And that's it. So. Also, I need more coffee. Okay, describe how your body detects gravity and acceleration. There we go. So gravity pushes these ear stones, the otoliths, against this gelatinous stuff, which bends the hairs of the hair cells in a certain way. But when you tilt your head, that changes the angle of the pull on the hairs of the hair cells, which is how you know that you just moved your head. So this is static equilibrium. It's how you can tell, like when you're laying down, if you're laying supine or prone, and if you're laying on your side or on your other side, if you're upright or not. It also helps with acceleration because if you're in a car and you take off, the otoliths lag behind a little bit and they pull a tiny bit on the hair cells when they do so. And just like I slam on the brakes, and then the otoliths are still moving forward a little bit and put a different tension on the hairs of the hair cells. Another part of static equilibrium is when you go up in an elevator, moving up pushes, because the otoliths are kind of still below, so pushes more on the hairs of the hair cells. And then as the elevator stops, there's kind of that weightless feeling for a second, and then there's less gravity pushing on the otoliths. Anytime we live in Rockport, so there's not like elevators or like much for second stories anywhere. But when we stay in a hotel, the kids always, and they're 11 and 14, so they're big kids, but they always jump in the elevator, like, and it's like a thing to like time it to get the best air in the elevator right before it stops, or to like to jump, like, and then anyway. Did they ever outgrow that? It's like the baking soda and vinegar thing. Like I keep expecting them to outgrow that, but no. No. We're gonna be at a hotel at one of their weddings, and they're gonna do like I don't think they're gonna outgrow that one. Okay, so that was page 22, and the timer says that I forgot to start the timer again. Okay. All right. Well, I am going to go ahead and upload page 22 because YouTube has been taking so long to upload these videos. And page 23 and 24, I think will go faster because I already covered those basic concepts in a previous video because I got ahead of myself because that happens. So this has been a video lecture of unknown length covering ANP2, lecture test 1, video 10? Yeah, note set, page 22. Wait, what's our next slide? Did I cover the whole thing? Yeah, that's the next page. All right. Thank you, as always, for tuning in. I will try to get this uploaded as quickly as possible. The education must go on. Dr. Jones out. Okay, Command Control Escape. What did I do with my keyboard? Okay, Command Control Escape. Have a good one, y'all.